Okay, let's get into it. Welcome to SAT Math. This is the second tutoring session I've done. If you guys didn't see the first one, it is posted on YouTube, and there's an answer sheet that goes along with it. I originally said I had it in the description, but I did not, so if you need that, just send me a text, and I will get that right to you. So first we're going to go over triangles. We need to learn some basic info about them before we do anything today, because this is going to be a main focus of our studying today. So all of the triangles in a triangle, no matter what, they always add up to 180. What I mean by this is if I drew a triangle, let's say this side's 90, this side's 45, and this side's 45. These angles add up to 180. If I drew this triangle, these angles are all going to add up to 180. This is really important to know because sometimes it asks you to find a third side in a triangle. And if you have two sides, it's easy. Just subtract those sides from 180 and then you'll get your third side. And there's also a lot more complex problems that will come along with this, and this is part of how you're going to solve them. Similar triangles. When an SAT question says there are two similar triangles, you want to know, no matter what, that all of the respective angle measures are going to be the same. So sometimes it'll give you triangle like ABC and then triangle EDF and say they're similar, where A corresponds to E, B corresponds to D, and C corresponds to F. And then they'll make the triangles. Let's say they make this one a little bit bigger. A, B, C, E, D, F. If A is 43 degrees, E is also going to be 43 degrees. Similarity in triangles means they have the same angle measures. Does not mean they have the same side measures though. This could be 5 and this could be 8. Those are just random numbers. I didn't use those numbers for any specific reason, just to show you that the side lengths could be different. So, a really important thing, my strategy, which has helped me succeed so well in the SAT, is every time I get to a triangle problem, I draw it out on my paper. And I'm going to be doing that with every problem today, because it is super important that you can visualize the problem. So, how should we draw these triangles? So, I see RST. So I always draw a right triangle. It doesn't necessarily have to be a right triangle, but I always draw a right triangle. If it doesn't say it's a right triangle, I just move on with my day and pretend it's not a right triangle. 63 degrees. And it's asking what S could be. So I'm looking for S. Let's say S is X. So we know all of the angles in a triangle add up to 180. So R plus S has to be less than 180. One second. Yeah, 63 plus X. That's what I meant to do. 63 plus X has to be less than 180. Because if those aren't less than 180, then that means, like, where's the angle measure for T? If, let's say you had 63 and 120, that's 183 degrees. That would never work, and T would have to be like -3 degrees, which isn't possible. The angles always have to add up to 180. So you see 63 plus X has to be less than 180, so subtract 63 over, and then X has to be less than 117, I believe. Yes, 117. So let's look at our answer choices and see what we have. We have 116, 118, 126, and 180. We know 180 is less than 117, or greater than 117, 126, and 118 are. So all of those can automatically be eliminated, and 116 is just going to be your answer. Any questions on this problem? If you guys have any questions, I will go back to the problem. In triangle ABC, the measure of angle A is 54, B is 90, and C is K over 2. It doesn't matter where you label your angles. I always do it differently every time, as long as I make a right triangle and put my right angle in the correct area. So let's say A, B, C. B is 90. So when a 90-degree angle is known as a right angle, and that's always going to be signified with a little square as the angle measure. A will be 54. I'll write 90 here. 90, 54, that's a bad 4. Okay, there we go. And the measure of angle C is K over 2. So this is K over 2. What is the value of K? Well, we know the angles in a triangle have to add up to 180. So 54 plus 90 plus K over 2 equals 180. And now you just have to solve for K because it's asking what the value of K is. So subtract 90 over and subtract 54 over. I'm going to do this at once. What is 54 plus 90 is 144. So I'm just going to subtract 144 over. 180 minus 144. So that gives me 36. So I'm going to move up here. K over 2 equals 36. Now to get rid of this 2 on the bottom, you have to multiply it over. So multiply both sides by 2. K is equal to 72. There is a lot of questions on the SAT where it asks about angle measures. You need to know a triangle adds up to 180. It is very important. Okay, next we're going to talk about right triangles. We have talked about right triangles a little bit, but these are important, so they deserve their own section. Right triangles are triangles that have a 90-degree angle. They always look like... The SAT will usually draw them like this. They will sometimes draw them like this, where your right angle would be your top angle. But they're always going to signify with it with a square. Sometimes they might state it's a right triangle in the question and not have the square, but when there's a right triangle, draw your triangle out and draw a little square for your right angle. The area is leg 1 times leg 2 divided by 2. What this means is you have 2 legs on a right triangle and you have a hypotenuse. A hypotenuse is going to be your longest side. It is always going to be opposite of your right angle. So you know the 2 sides that connect to your right angle are going to be your legs. So let's say this was 8 and this was 4. 8 times 4 times 1 over 2. It's leg 1 times leg 2 divided by 2. You could do 8 times 4 times 1/2, or you could do 8 times 4 over 2. Either way works. And you will get 16 if you put that in Desmos. So that's the area of a triangle. Those aren't asked too much on the SAT, honestly, but you'll see a problem every now and then, and it is important to know. So next, this is probably your most important triangle topic overall for the SAT. The Pythagorean theorem. A squared plus b squared equals c squared. That up arrow means squares. The equation looks like this. If that up arrow is confusing to you. So, what would this look like on a triangle? So you have your right triangle, and your C is always going to be your hypotenuse. This is C. It doesn't matter which ones these are. This could be B, and this could be A. This could be A, and this could be B. It doesn't matter what those two are. But C can never change. C is always your hypotenuse. So, with this theorem, with any right triangle, you can find the last side length if you have two side lengths. If you subtract over a squared, you have b squared equals c squared minus a squared. And then the opposite if you subtract over b squared instead of a squared. So you can use this formula to find any side length you want on a triangle as long as you have two side lengths. And that is heavily tested on the SAT. So, which equation shows the relationship between the side lengths of the given triangle? Always, even though I see it, I love to draw out my triangles. This is 19, this is 4, this is B. Capital B, lowercase, doesn't matter too much. So, to find the last side, I need to use Pythagorean theorem, which is a squared plus b squared equals c squared. C squared is always your hypotenuse, so we know that b is going to be one of these side lengths. So subtract over a squared since they already have it labeled as b. So b squared equals c squared plus a squared. And then plug in c and a, which is going to be your 4 and 19, your other two side lengths. B squared equals 19 squared plus 4 squared. And now we will head up into Desmos to do that. 19 squared plus 4 squared. That equals 377. So b squared equals 377. But don't stop here. That b is still squared. We need to get rid of that square. So we're going to square root the whole thing. So b is the square root of 377. So I do 377 to the 1/2. You can find the square root in here if you want to. I always just use the 1/2s, the 1/3s, the squareds. So this would be 19 point... Oh, I did it wrong. It's c squared minus a squared. The reason I caught that mistake is that I noticed that my side angle was bigger than my my hypotenuse, which can never happen in a proper right triangle if you're using Pythagorean theorem. 19 squared minus 4 squared. So the square root of 345 would be 18.57. Oh, this one just gives you the equations. So, I was looking for the angle. You can see the a squared plus b squared equals c squared. These bottom two are your Pythagorean theorems, so you know it's not going to be a or b because you're using Pythagorean theorem to find that last side. And then it's a squared plus b squared equals c squared. You haven't subtracted anything over quite yet. So the answer would be C to this one. For the triangle shown, which expression represents the value of A? So this one doesn't give me a final answer, so I am going to solve it out. This is why I need to look at the answer choices first, because I did a lot more work than I had to right there. So I draw out my triangle, which expression represents the value of A. A is a side length. This is a 6. So A squared plus B squared equals C squared. You're trying to find A, so A squared equals C squared minus B squared. What I did in this last part is I subtracted over the B squared to cancel it off of this side. Now to find A, you want to square root the whole thing, so A equals the square root of C squared minus B squared. And C is always your hypotenuse, so plug in C. This is 21 squared. B is 6 squared. So your answer would be 21 squared minus 6 squared. Alright, similar triangles and dilation. Dilations are another thing that are not that important in my opinion on the SAT. You don't see many of them, but the SAT does have a trick question with dilations, which we will go over. Anyways, what you need to know about dilations is dilations are the side lengths of a triangle times a scale factor. So if they had A, B, C, and they said A prime, B prime, C prime was dilated by a scale factor of 2 from ABC. If ABC was like 4, 4, 6, then A prime, B prime, C prime would be 4 times 2, which is 8, 8 times 2, or 4 times 2 again, which is 8, and then 6 times 2, which is 12. So you're just multiplying all the sides by whatever the scale factor of the dilation is. Similar triangles, we talked about them a little bit earlier, but they're very important. Similar triangles, like I said, have the same angles. If you see two similar triangles, no matter what, you want to know that it is always the same angles, same angle measures. They also have proportional side lengths. So what I mean by this is if you have, let's say, ABC, and it is 3, 5, 6, and it is similar to EDF. This triangle is just bigger. Well, we know these all have the same side lengths, so it doesn't matter what these side lengths are. A matches up with E, C matches up with F, and B matches up with D. So, proportional. We know, let's say this side length is 6, and we wanted to find DF. So what I would do here is BC to BA is 5 over 3. And you set it equal to DF to DE, which would be x over 6. So proportionality, you can just do a fraction of two side lengths over each other. And then you can do it for the other similar triangle, and that will allow you to find the last side length. So then you would cross multiply. Actually, you don't even need to cross multiply. Multiply 6 over, that would be 30 over 3. 30 divided by 3 is 10, so x would equal 10. And there is a very common trick with dilations and similar triangles on the SAT. So, EDF is a dilation of ABC. And these triangles are still similar. So if you have triangles that are similar, in the SAT says there's a dilation and it still wants you to find the angles of a triangle, the angles remain the same. Dilation does not affect the angle measures of a triangle. We will see that in this problem. In the figure shown, CAE is similar to CBD. The measure of angle CBD is 57 and AE is 26 times BD. What is the measure of CAE? So I'm going to draw this out. BD. And then you have C. And then you have A and E. So it shows that these two are right angles. And CAE is similar to triangle CBD. So that means these angle measures are the same. The measure of angle CBD is 57 degrees. So CBD is 57 degrees. And AE equals 26 BD. So whatever the line segment BD is, AE is 26 multiplied by that. They're basically saying that the bigger triangle is scaled up by a factor of 26. That doesn't matter though. They say there's a dilation there. Disregard that dilation because we're trying to find an angle measure. CAE, we already know, is going to be the same as CBD. So this is going to be 57. That dilation right here does not matter at all. So we can move on with our day, ignore that dilation, and save a bunch of time on that problem. Right triangles PQR and STU are similar, where P corresponds to S. If the measure of angle Q is 18 degrees, what is the measure of angle S? Okay, so let's draw this out. As you guys have noticed, I've drawn every single triangle out. It's literally the best way to make sure you get triangle problems right on the SAT. So these have the little square in the side, so you know they're right triangles, and this is 90 degrees for each of these. And it gives us that the measure of angle Q is 18 degrees. It wants us to find an angle on STU, so we need to know two of the angles. Well, we know angle T should be equivalent to angle Q because these triangles are similar, and T will correspond to Q. So we know that this is going to be 18. And since we know, let's set this to x plus 18 plus 90, we know all the angles are always going to add up to 180. So now we would just type that into Desmos. We would subtract over the 90 and the 180. So 180 minus 90 minus 18 is 72. 72 degrees is one of our answers. Answer choice is B, and we move on. Okay, here's another practice problem. Rectangles. Uh-oh. Let's get back to where we were. Oh, there we were. I don't know what happened. Anyways, rectangles ABCD and QRST are similar, where ABCD responds to QRS and T respectively. What is the length in inches of AD? So you have A, B, C, and D, and then you have R, Q, R, S, T. So it's given that these triangles are similar, which means their sides are going to be proportional. They want you to find AD, so set AD to a variable such as X. So now we would put QT over QR as 10 over 5. And then we would equal it to AD over AB, which would be X over 12. This is the proportional side lengths thing again, because similar shapes have proportional side lengths. Once you know that, you can set up an equation to solve for X. So you would multiply 12 over. First, actually, 10 over 5 can be reduced to 2. So 2 equals X over 12. And multiply 12 over, and then X would give you 24. That was an answer choice, right? Yep, 24. If you guys have any questions or need me to slow down at all, just let me know. Vertical and supplementary angles. So vertical angles are angles that are across from each other, and what they are is they are equal in angle measures. So you have no clue what I'm talking about right now unless you know what vertical angles are right now. So I'm going to draw out a situation for you. Say you have these two lines intersecting. These two lines are across from each other, and they are going to be vertical angles. They will be equal. These two lines are also across from each other, and they are vertical angles, and they will be equal. So let's call these A and B. A would equal B, and let's call these C and D. C would equal D. And then supplementary angles. These are angles that add up to 180 degrees. And what does this look like? So you can use the same picture for supplementary angles. If you have two lines, if you have one line crossing through another line, it makes two angles, and those two angles will add up to 180. Let's say I didn't have this line crossing through here. This is a 180 degree angle. A straight line is just a bunch of 180 degree angles. So if I push a line through it, that's going to cut that 180 into two different parts. So let's call these B and D again. Let me stick to how it was before so the other stuff remains true. B and D will add up to 180. Because it was 180 before, and you just know those two crossed, and it split up that 180. So B and D will add up to 180. And that goes the same for A and C, because this is a line right here that's 180. Once you split that, A and C equivalent to 180. Also goes the same for A and D. This line is a line right here that's 180, so A plus D would be 180, and so would D and B. So that is what supplementary and vertical angles are. Vertical angles are the angles that are across from each other in an intersection, and they will be equal in angle measures, and supplementary angles are the ones that are next to each other in an intersection, and they will add up to 180 degrees. Practice problem. In the figure, line M is parallel to line N, and K intersects both lines. Which of the following statements is true? If it's a tough one of these, I might draw it out, because some of these are pretty tough questions. They make hard versions of these. This is X and this is 145. And K. Well, we want to find out the measure to angle X. We see that this is one line right here. So this line that intersects it will make two equal angles on opposite side. X and 145 are vertical angles, which means X would be equal to 145, which is C. In the figure shown, lines R and S are parallel, and line M intersects both lines. If Y is less than 65, which of the following must be true? So, draw this out. Again, most of these I probably wouldn't be drawing out on the SAT because these are easier versions of the problem. But it is good to know. So the important thing in this question is R and S are parallel, which means that M is going to be creating the same type of angles through R and S. So X would equal whatever this angle is. Not Y. Let's call it Z. So X equals Z, and Z plus Y, because we can see that this is a line by itself and M is just splitting these two, would add up to 180. So we know that X and Z are equal, so that means Y plus X equals 180. 180. If Y is less than 65, what must be true? So, let's see what it looks like in Desmos. I'm going to do C plus B, and then I would do C plus X equals 180 because I want C to be a constant. And then I'm going to zoom out a little bit, and then I'm going to make a slider for C. You don't really have to do this. You could really just subtract 65 from 180, and that'd be 115. Since Y has to be less than 65, X would have to be greater than this number. But let's set C equal to 64, and then we can get that slider pulled up. We know Y is less than 65. So if we keep going, we know this point is at 116. It's only going to get greater as Y goes down. So the X has to be greater than that number 115 right there. SOHCAHTOA, this is a very, very important topic on the SAT as well for triangles. I would say this is probably your second most important, right behind understanding Pythagorean theorem. So SOHCAHTOA, you can use it for most triangles, but on the SAT, I've never seen it on anything other than right triangles. So let's draw a right triangle out to show things. As I said earlier, the hypotenuse is opposite of the right angle, so that would be H. And then sine of an angle would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. So these deal with angles. Let's say this angle is called X, this angle is called Y, and this angle is called Z. We know Y is 90 degrees, but these angles reflect the sides. So let's say we had sine of X. Sine is opposite over hypotenuse. HIJ. I'm just going to call the outside HIJ. So sine of X would be opposite. Opposite of this angle is this portion. So I. And then over hypotenuse. Hypotenuse is opposite of right angle. So it would be I over H. Cosine of X would be adjacent over hypotenuse. So the adjacent line to cosine of X that is not the hypotenuse is J over H because it's over the hypotenuse. Sine of Z, let me put that in a better, I'll just eliminate these two. Sine of Z would be opposite of sine angle is J over the hypotenuse is H. And then cosine of Z, adjacent of Z is I, and hypotenuse is H, so it would be I over H. So that is kind of how you use your SOHCAHTOA angles. So means sine opposite over hypotenuse. Ka means cosine adjacent over hypotenuse. Toa means tangent is opposite over adjacent. I guess I didn't show any tangent ones. Let me show a tangent one real quick. Let's call this X, Y, Z, H, I, J. Use the same thing. J. Tangent of X would be opposite, which is I, over adjacent, which is J. You're always going to have two adjacent angles to your triangle. Just know it's never going to be the hypotenuse. The adjacent is the smaller of your angles. Okay, here we go. Let's draw out this triangle. 53 RST. The triangle shown RS is the square root of 105. What is sine of R? So if we go back to our SOHCAHTOA, the so part of it is sine is opposite over hypotenuse. So sine would be this line. Let's just call it Y for now until we find it. Over hypotenuse, and your hypotenuse is going to be opposite of the right angle, which is 53. So sine of R equals Y over 53. We want to find the actual value of sine of R, so we have to find Y. And since this is a right triangle, we can use the Pythagorean theorem to find Y. So we know Y is a side angle. Let's just call this B instead so we can stick to the formula. A squared plus B squared equals C squared. Plug your stuff in. Square root of 105 squared is A squared because C is always the hypotenuse. We can just call that 105 plus B squared equals 53 squared. Now I'm going to go over and do that math in the calculator. 53 squared is 2,809. We need to subtract this 105 over. Minus 105 is, that's 195. 105 is 2,704. So b squared equals 2,704. Remember, we cannot end it here. We have to get rid of that squared with a square root over everything. B is equal to the square root of 2,704 to the 1/2, which is the same thing as the square root. So B is equal to 52. Okay, the side lengths of right triangle RST are given. So this is a right triangle RST. Before I draw out the angles, I want to figure out which is the right angle. Well, TR is the biggest, so that's the hypotenuse. TR is 52, which means S is the right angle. And then ST is 48. And RS is 20. Okay, so it wants to find the value of tangent of W. Oh, this triangle is similar to UVW. Okay. S corresponds to V and T corresponds to W. UVW. So this would make, we don't know any of the side lengths to this one. That is a Z. But what we do know is that in similar triangles, the sides are proportional. So the tangent of W, which is x over y, which is opposite over adjacent, because in our SOHCAHTOA, the TOA means tan is opposite over adjacent. The tangent of W is going to be x over y. And x over y is equal to 20 over 48, because these angles, these lines are going to be proportional to each other. So we just have to simplify 20 over 48. You can divide each of these by 4. So that'd be 5 over 12. So the answer would be B here. Triangle, this second part bottom here is another problem. Triangle ABC is similar to triangle DEF, where angle A corresponds to angle D, and angles C and F are right angles. The length of AB is 2.9 times the length of DE. If tangent of A is 21 over 20, what's sine of D? So let's draw out our two triangles. C and F are right angles. ABC, DEF. The length of AB is 2.9 times the length of DE. So that's called D. Oh, the length of AB is 2.9 times the length of DE. So if we call DEX, then AB is 2.9x. Oh, this is AC. So this looks like we have a scale factor of 2.9 for our dilation. It would go from DEF to ABC, and it would be a scale factor of 2.9. With SOHCAHTOA, we disregard dilations again because they're proportional. So if tangent of A, let's go to A, tangent of A, so that's opposite over adjacent, is 21 over 20. What is the value of sine of D? Well, I'm just going to find the third angle to ABC because once I get Pythagorean theorem, I can use the proportional angles to find what sine of D is. Because sine of D, so that would be opposite over hypotenuse. So sine of D equals x over y. So we need to find AB, so we can put CB over AB and find how it's proportional. So AB is the hypotenuse. This would be your C squared. So it would be A squared plus B squared equals C squared. 20 squared, I'm plugging in now, plus 21 squared equals C squared. 20 squared plus 21 squared equals C squared. Oh, I don't know why I put the C squared in there. Well, we solve for this side. We have 841 equals C squared. Now, I gotta square root everything to find C. C will be 841 to the 1/2. I did 1.2 again. To the 1/2 is 29. So C equals 29. So this is 29. And now we can put CB over AB. So we can find sine of B, or sine of D. So that would be 21 over 29. Because x over y equals 21 over 29 because they are proportional to each other. So sine of D equals 21 over 29. Let's see if that is an answer choice. It doesn't give us any answer choices. But that should be the correct answer. Okay, let's go ahead and take a 5-minute break here, just so I don't wear you guys out. We're going to start back up at circle equations. Okay, let's get started again. On to circle questions. So, a lot of people, I notice, I want to give a little spiel before I go into this. A lot of people are super afraid of any sort of circle question on the SAT. There are some circle questions that are somewhat scary, and there are a lot of harder circle questions on the SAT. But most circle questions on the SAT aren't even circle questions. They are triangle or trigonometric questions. And although you should probably know the circle equation because there's going to be a few problems on each SAT that is going to use the circle equation to get you somewhere, it's not like the most important thing in the world. Circle equations are not as scary as people think. Okay, so this is what the equation looks like, and I am going to break this down for you guys. A is your x value, B is your y value, and the center of the circle equation is AB. So let's say x minus a squared plus b minus y squared, x minus, x minus a squared plus b y minus b squared equals r squared. So this is not going to pop anything up. But let's go back to the home part. So let's say I had a circle with center -4, 8. So this is your x value, this is your y value. We know from the circle equation that a is your x value. So plug in -4 to a. A equals -4. B equals 8. And let's just set r to something. Let's say the radius of this circle is 4. So r equals 4. So this is our circle. As you can see, its center is literally right at 4, 8. And the radius is 4. So this is how you would see it. You can also, r squared is 16. Let's just plug in 8 for b. And then since it's minus a, it would be minus -4, which is plus 4. So this is literally the same equation as what I just did, instead of setting the variables equal to something. So that is how your a and b works and your r on the SAT. And like I said earlier, many of these questions are not circle questions. It is not as scary as people think. I would master triangle questions before I mastered circle questions on the SAT, because many of the circle questions you don't need to use anything from the circle formula at all. And r being squared is important. Sometimes it asks you to find the radius of a circle, and it gives you the circle equation. All you have to do is square root the value over on the side, if it is in this form. If it is x minus a constant squared, y minus a constant squared, equals some constant here, just square root that constant, and you will get the radius of the equation. Let's look at some. A circle in the xy plane has its center at 16, 17 and has a radius of 7k, which represents this circle. So let's write out our circle equation. X minus a squared plus b minus, or y minus b squared equals r squared. So let's plug in each number. It's given that our center is 16, 17. This is our x value, this is our y value. So a is your x value, so you would plug in 16 for a, x minus 16 squared plus y minus 17 squared equals, and it gives us our radius. It says radius is 7k, so it'd be 7k squared. When you do something like this, you have to square both the coefficient and k, so 7 squared is 49, and then k squared is k squared. So it'd be 49k squared. So it should be x minus 16 squared plus y minus 17 squared equals, this isn't right because this is just 49k. This first part is right, and 49k squared. So this is what your answer is going to be. It should be B. This is 7k and this is 7k squared. So those two are wrong. Circle A has the equation x minus 7 squared y plus 3 squared equals 1. In the xy plane, circle B is obtained by translating circle A to the right 4 units. Which equation represents circle B? X minus 7 squared plus y plus 3 squared equals 1. If you're translating a circle, I would go based off its center. So we see this negative 7 here. That means the x value is 7. We see this positive 3 here. That means the y value is negative 3. And now I know my center is 7, negative 3. So if I'm going to the right 4 units, that is going to affect your x value. The right is going to be positive ways. So you would go from 7, 7 plus 4 would be 11. So your new center would be 11, negative 3. Plug this back into your equation. X minus 11 squared plus y plus 3 squared equals 1. And it will be C. A circle in the xy plane has its center at negative 1, 1. Line T is tangent to this circle at the point 5, 4, negative 4. Which of the following points also lies on T? So, some of these circle questions you do have to draw out. So let's draw a circle. And you have center, negative 1, 1. And then you have a spot at 5, negative 4. So this is 5, negative 4. And then it says line T is tangent to the circle at this point. And which of the following points also lies on line T? So a tangent line to a circle is where it only touches this circle at one singular point. So it's going to be perpendicular to whatever this line is. So this is what a tangent line kind of looks like. It forms a right angle with your radius to whatever point out you have. So we want to find the equation to line T, because finding the equation to line T would help us figure out what point's on line T. So what I would do to find the equation to line T, we need to find the slope, because we already have a point. We need a slope and a point to find the equation. So we have negative 1, 1. This is x, this is y. And then 5, negative 4. This is x and this is y. To find the slope, we use a slope equation, y2 minus y1 over x2 minus x1. If you guys don't know this equation or need help reviewing or understanding this equation, just let me know. This equation is the slope. We set this one to y2 since these are the bigger numbers. So negative 4 minus 1 over 5 minus negative 1. This would be 6. This would be negative 5. So your line is negative 5 over 6. Your slope to that line. So we know if a line is perpendicular to its other line, then it is opposite reciprocal. So the slope of line T is going to be 6 over 5. So now we know line T is going to be y equals, your slope is before m, so 6 over 5 x plus b. And now we need to use our point that is on line T, which is 5, negative 4, to find B. 5 is x, so plug in 5 for x, and then negative 4 is y. Negative 4 equals 6 over 5 times 5 plus B. These 5's will cancel out. This will give us 6 right here. Subtract the 6 over, and B equals negative 10. Now you have your full equation. Y equals 6 over 5x plus minus 10, since it's negative 10. Y equals 6 over 5x minus 10. So we want to find which coordinate lies on this. Let's look. 0, 6, 5. When it's at 0, it's at negative 10. 4, 7. When it's at 4, it is at negative 5.2. 10 and 2. When it is at 10, it is at 2. So 10, 2 is going to be the point that lies on our slope. This is quite a confusing question. Yeah, it's quite a confusing question. If you guys have any questions on it, just let me know. I'm going to type in the, I don't have the radius to the line. I could find the distance and it'd give me the radius, but yeah, not right now. Okay, now areas and volumes. This is for squares and rectangles. Area is going to be your length times your width. Volume is going to be your length times your width times your height. Perimeter, to find the perimeter, you add up all of the sides of your square or your rectangle. These questions are very popular on the SAT. Just knowing area, volume, and perimeter, if you didn't know this before, you're going to get like 4 or 5 extra questions right, just based off of that. I've seen plenty of questions on this for every SAT I have taken. Shouldn't change anytime soon. This is very important to know conceptually because they ask weird questions about this. You can know this, but they can ask a super weird question to you, and it ends up being like practically impossible to find anyways. So visually, call that a square. Call this a rectangle. You have your length and your width. You have your length and your width. This would also be width. This would also be length. These two are separate. This would be width. This would be width. This would be length. To find the area of these would be your length times your width for both of these. That is what area looks like. If this was 5 and this was 8, you would do 5 times 8. 5 times 8 equals 40, so your area would equal 40. Oh, okay. Triangle R has an area of 80 square centimeters. Square S has a side length of 4 centimeters. What is the total area of triangle R and square S in centimeters squared? So we know triangle R has 80 square centimeters, and we want to add up the total area of triangle R and square S. So it's going to be 80, because that's the area of triangle R, plus the area of S. So let's just put that as A. We know the square S has a side length of 4. And squares have the same side lengths on all 4 sides, so it would be 4 times 4, or 4, 4, 4, and 4. We know area equals length times width, so length and width, 4 times 4 would be 16. The area of this is 16. And then if this was centimeters, it's automatically going to be centimeters squared when you find the area. It's automatically going to be centimeters cubed if you were finding the volume of a cube. That's kind of important to know, because when converting for units, you have to square root those centimeters and stuff. So now we know area is 16 centimeters squared. So 80 plus 16 is going to be 96. So your answer would be 96. The area of a rectangle is 57 square inches. When I put areas in on the SAT, I always like to put the area on the inside. The area of this rectangle is 57 square inches. The length of the longest side of the rectangle is 19, so we know this is 19. What is the length of the shortest side of the rectangle? Let's put that as x. This is your length, this is your width. Area equals length times width. So now you can plug in 57 equals 19 times x. To get rid of this 19, you would divide both sides by 19, and then x equals 3. So that would be the length of the shortest side of the rectangle. You're basically reverse solving from the area to find the side length. What is the perimeter in inches of a rectangle with a length of 4 inches and a width of 9 inches? So we have a rectangle. It has a length of 4 inches, so 2 of the sides are going to be 4 inches, and a width of 9 inches, so 2 of your sides are going to be 9 inches. So when you're asked for the perimeter, you want to add up all sides, so it'd be 9 plus 4 plus 9 plus 4. 9 plus 4 is 13, plus 9 is 22, plus 4 is 26. So your answer would be 26, which is D. Surface area practice problems. In this what I was talking about when I said this is important to know conceptually. So when you're looking for volume, a lot of the times it is going to give you a volume or give you a cube, and they want you to find the surface area. This is really tough to conceptually understand. So a right rectangular prism, I like to draw out my right rectangular prisms. That just means the rectangular prism has all right angles. Has a length of 28 centimeters, a width of 15, and a height of 16. It wants you to find the surface area of the right rectangular prism. So surface area is the area of each side of the right rectangular prism put together. So there's going to be 4 sides with this area because 1, 2, and then the bottom side and the other side will all have this same area because you're multiplying it by the same height. And then there will be 2 with the area of this square part right here, which would be 16 times 15. So it would be 4 times the area of this. Let's set that as x. 4 times x. And then 2 times this, which would be y. Because you want to find the total area. You're adding up the total area of all these different pieces of the rectangular prism. That is why it's surface area, because you're not going on the inside at all. So y, the area of this, is going to be 16 times 15. So it's 2 times 16 times 15. And then you're adding this 4 times x to it. The area of this, which is x, is going to be 16 times 28. So it would be 4 times 16 times 28. So I would go into Desmos to solve that. 4 times 16 times 28 plus 2 times 16 times 15. And that would give you 2,272, which should be your answer. And like I said earlier, if they were asking for units. Since you're multiplying all these in their centimeters, since it's surface area, it's actually going to be centimeters squared. All of this is going to end off in centimeters squared, whatever your answer is. So it'd be 2,272 centimeters squared. A cube has a volume of 474,552 cubic units. What is the surface area in square units of the cube? So we have ourselves a cube. And this cube has a volume V equals 474,552. And it wants to know what the surface area of the cube is. To find the surface area, we have to find the area of each square and add it all up together. Since it's a cube, we know the length, width, and height are all the same. So this would be, we could set these all to x since they're equal. And length times width times height gives you volume. So the volume of a cube is actually x cubed. So x cubed will give you 474,552. So to find what one of the side lengths is, you would cube root x. So 474,552. This is why I find 474,552. This is why I find using the fractions in the exponents easier, because I can just go up to the 1/3. I don't believe there's a cubed root in here. Yeah, there isn't. So if you need to do a cubed root and you don't know how to do the fraction thingy, you basically just can't do it. So now we have a side length. Let me draw that cube back up. The side lengths of each of these is 78. And since this is a cube, each side is going to have the same area. So we can just find the area of one side and multiply it by 6, because that would be 78 plus 78, or area plus area plus area. Multiplying it by 6, you would add each side over. So let's find the area of one side, and then we can just multiply that by 6. The area of one side is going to be 78 times 78. So it will be 78 squared times 6. That is going to give us the surface area. Which is 36,504. The length of each edge of a box is 29 inches. Each side of the box is in the shape of a square. The box does not have a lid. What is the exterior surface area in square inches of this box without a lid? This one's kind of hard to draw. I'm going to do my best here. This part's open. I'm just going to fade that in as that part is open. There's no side right there. So we know the length of each edge of the box is 29 inches and each side of the box is in the shape of a square. That means this box is in the shape of a cube, so we know the length, width, and height are all going to be 29. And is asking for the exterior surface area in square inches of this box. So there's only 5 cubes on this box here, so we need to find the area of 1 and multiply it by 5. So the area of one of these cubes is 29 times 29, which would be 29 squared. Multiply that by 5, and that will give you your exterior surface area. Which would be 4,205. Are there any questions on any of these problems? Okay. Area and volume of a circle dash sphere. This one's not too important, but you'll see a question on the SAT now and then for these types of questions. For each of the equations I'm going to show you here, R is the radius. And the radius of a circle is 1/2 of the diameter. So this is the radius of a circle. It basically goes from the center to any external point. And if you double that, you'll get the diameter, which is the full circle all the way across. So this whole line is diameter. Half of this line is radius. That's important conceptually to understand, so you know what you're looking for if they give you a visual problem on the SAT. The area of a circle is pi r squared. I'm going to write this out because it's going to be easier to look at. So area equals pi r squared. Volume equals 4/3 pi r cubed. Volume equals 4/3 pi r cubed. And then circumference of a circle is 2 pi r, and I'll explain to you what that circumference means. So the area of a circle is basically covering the whole inside of a circle. That's what you're finding when you do pi r squared. The volume would be the area of a sphere. I don't know how to draw a sphere, so I'm not gonna try to do that. The circumference of a circle is the length of the outside of the circle. So you're looking for whatever the length of the full outside of the circle is. That is your circumference. So, what is the diameter of a circle in the xy plane with equation x minus 5 squared plus y minus 3 squared equals 16? So this is where it's very important to know the circle equation, because we know it's x minus a squared plus y minus b squared equals r squared. And where is our radius? Our radius is right here. Since this equation is completely in circle formula, to get the radius, you would just square root 16. So r is the square root of 16. So let's go into Desmos and do that. It should be 4. Yep, it's going to be 4. So we know the radius is 4. If the radius is 1/2 the diameter, and we're looking for the diameter, plug in 4. 4 equals 1/2 diameter. Multiply it by 2 and you'll find your diameter. The diameter is equal to 8. So it would be B. A sphere has a radius of 17/5 feet. What is the volume in cubic feet of the sphere? For spheres on the SAT, I just draw out a circle. I know the radius of this circle is going to be 17 over 5. So now what you want to do for this circle is, if we go back, the volume of a circle, or the volume of a sphere, is 4/3 pi r cubed. So you have pretty much everything you need. All you got to do now is plug in. So 4/3 pi r cubed. That's what your volume equals. So plug in pi. 4/3 pi times your radius, which is 17 over 5. And then cubed is equal to 164.36. It gives us these in pi, 5 pi over 17, 65 pi over 8, so they're not in the right form. So I would personally just plug all of these in. Let's see what 5 pi over 17 is. That's 0.92, that's not going to work. 68 pi over 15ths. That's 14, that's not going to work. I see 32 pi over 5, but that already doesn't look big enough to me. Let's go to the D. 19,652 pi divided by 375. And this is equivalent to my 164.6362. So the answer of this is D. A circle has a radius of 43 meters. What is the area in square meters of the circle? So the circle has a radius of 43 meters, and we want to know the area of the circle. Area is pi r squared. As we can see here, area was pi r squared. So now we would just plug in r, go over to Desmos, pi r squared, plug in 43 for r, it gives me 5808. And I know that pi r squared, pi times 43 squared isn't equivalent to this or this, and then if you square a number, you're not just doubling it, so it can't be C either. I'm going to plug in D just to make sure, but it should be D, and it gives me the exact same number, so it's going to be D.